Good evening, everyone. Good evening. Hope all is well. Hope everyone's doing all right. Got one more trying to connect with audio. So let's see if we can get in there first. All right. Like she's still trying to connect, but it's all good. Okay, so I hope everybody's doing all right. Everybody's okay. Everybody enjoyed their extended weekend, holiday weekend. Um, Before I do anything, did anybody have any questions? Try anything out in chapter two? If I'm not mistaken, we finished out to 2.6. So that was all of chapter two.
I have a few questions.
Yep.
They're actually from the review, the chapter 2 review.
Mm-hmm. All right, let me pull it up. Where it go? All right, which number are you looking at?
Number 2, the finding the slope of a curve at a given point.
Okay. Hold on, why is this not? Hold on 1 second. Let me go in there and come back up. Two. All right, so all right, so just type this problem right here, find the slope of the curve, y equal to x squared minus 3x minus 2 at the point 3, -2. I'll find the limit of secant slopes through point P. Find the equation of the tangent line. All right, that is the problem you're talking about, right?
Yes.
Okay. Trying to see what I did there. Yeah, I thought so. All right, so go to review. All right, and I lost my, here we go. All right, so we have the curve y equal to x squared minus 3x minus 2 at the point 3, -2. And then we want to find the equation. Okay, so all right, first thing we can do is find the difference quotient. All right, so we have f of x because y. So y and f of x are the same thing. So we have f of x, but we need f of x plus h. So we're gonna plug in x plus h where we see x. And then expand it out. So you know this right here is distribute that. So we expand out x plus h times x plus h should give us x squared plus 2xh plus h squared. Then distribute the -3, which would be -3x minus 3h, and then minus 2 is still back there. So all of that is f of x plus h. And so now we can actually plug this in, where we see f of x plus h. It's 3x, right? So that's what we're looking at now. We have that f of x plus h, and then minus f of x, and that's all over h. Distribute this negative. And I'll just go ahead and write it all out again, just to make sure everything's okay. So now what's supposed to happen is that every term in the numerator that does not have x should cancel out for us. So in other words, x squared minus x squared cancels. 3x minus 3x, positive 3, well, negative 3x and positive 3x. And then we have -2 and positive 2 cancels. So what's left is 2xh plus h squared minus 3h all over h. So we'll make sure we're okay before we keep going. As a matter of fact, let me do it like this. And now this h goes into each. And we can simplify that. This is going to cancel one of our h's. Let's cancel this one out. So that'd be 2x plus h minus 3. All right, so now we can go ahead and apply the limit. So we take the limit of it as h goes to 0. So that means that's 2x plus 0 minus 3, which is 2x minus 3. All right. So I guess I could have wrote apply the limit. So let me do this, trying to write some steps. I guess I could have started off writing steps. I'm gonna go back up. So the first thing we did, or we should have done, was find the difference quotient. All right, so the first thing we did, find the difference quotient. That's what this is right here. All right, then second move was to apply the limit as h goes to 0. And of course, that's just plugging in 0 where you see h. That's why h needed to cancel out here, because putting in 0 right there, you have 0 in your denominator. So that would be undefined. So that's why all of your h's have to cancel. Well, your h has to cancel out into each term that's left. And now we're going to evaluate 2x minus 3 at the point. So the point they gave us was 3, -2. And that means that, let me do it like this. That means x is equal to 3. So that 2x minus 3 is going to represent my slope. And I can plug in x there. So our slope should be 3. Yep. All right, so before we go to get the tangent line, are you okay with how we got to our slope? Use the difference quotient to get our slope.
Yes,
That's yes, you have a question, or yes, you're good?
I'm good
Okay.
right now.
All right. So then the fourth step, they ask us to find the equation. Equation of the tangent line. And let's see, I want to write. Use point slope formula. All right. So they gave us the point, which is 3, -2. And we calculated our slope, which was 3. So we use those two pieces of information to now plug into the equation or into the formula. So that's what we're looking at. 3 for x1, -2 for y1, and then 3 for your slope. Go ahead and distribute. And also negative to negative turns positive. And finish it off. I subtracted 2 from both sides. So that should be our equation. Yep, that's all they wanted from us. All right. Anybody have any questions on that one before we go to another one? I think she had more than one question, but is everybody good on what we just did? As a matter of fact, that was a great segue to 3.1. 3.1 is just that, it's that same thing. That whole process is 3.1. So when you go into 3.1 homework, it's that, you do your difference quotient, find your slope, then the equation of the tangent line that uses that slope. So just give you a heads up. So new material won't happen until we get to 3.3, because we do 3.1 then 3.3. I got to look and see why. I think 3.2 was a background section, so I didn't really make the class do that last time. So we just did 3.1, then go to 3.3. But 3.1 is the same process. They just rehash it So just throwing that out there. All right. Did you say you had another question? Or was that it?
Yes.
Okay.
Number 10 on the review.
All right. Let me go there. Okay. Yeah. Well, let me use 1 over b minus 1 over 3. All right. Let me make sure I got it all the way. 1 over v minus 1 over 3 over v minus 3. All right. So we have 1 over v minus 1 over 3 over v minus 3. And it wants to find the limit as v goes to 3. So of course, in its current state, it wouldn't be beneficial to us because if we were to plug in 3 right here, we would get 0 in our denominator. So that does not help us. So let me see. So now if I were to multiply top bottom by 3v, still plug in 3, that wouldn't be good. All right, so let's try this. Let's multiply. So let's try to multiply each numerator by the LCD. And we're talking about common denominator of each one of our denominators. So like a LCD is going to be 3v. So each term needs to be affected by that 3v, multiplying each numerator by the 3v. Let me see, do I want to, let me do this. Instead of doing this bottom individually, I'm going to do it like that. Don't need to do that individually. Okay, so.
Mr. Tucker,
Yes.
how would we know what the LCD is?
Well, it's about when you look at the denominators that you have. So the legit denominators that we have are 3 and v. You know, this is one solid. How would I say it? So we have 2 numerators in our denominator that do not have a fraction, that aren't fractions. You have v and 3. So what we have right here is a complex fraction. So you know this is just a regular fraction. But whenever you have more than one thing going on, in other words, if I were to put another fraction here, let's say I go 1/2 plus 1, that's considered complex because now what we have here is 1, 2, 3 fractions. So it's considered a complex fraction. So whenever you want to simplify a complex fraction, you look at your terms in each. So you have 1 term, 2 terms, 3, 4. Out of those 4 terms, there are only 2 denominators. You know what I'm saying? If you were to look at those terms individually. So you look at those 2 denominators and you ask yourself, what's the LCD between those 2? And so we got V and we got 3. And so there's nothing in common with a V or a 3. So we just multiply those 2 together. Now it would be different if this was a 9 right here. Then we could say the LCD is 9 because that's the smallest number that both 9 and 3 can divide into evenly. They can, you know, 9 can divide into itself as well. But if you were to put a V right here, the smallest term that both 3 and V can divide into evenly is just 3V, just multiplying those 2 numbers, those 2 terms together. So hopefully that helps.
Yeah, that makes sense now.
Okay, cool. All right, so once you do that, when you multiply each numerator by that LCD, what should happen is that it cancels out the fact that you have fractions. So V's cancel in that first term, leaving you with just 3. Then that's minus when the 3's cancel, leaving you with V. And then here, I didn't distribute that 3V because of what's going to happen in a second. All right. So now, if we keep going with our cancellation, we know we're not finished because if I plug in 3 right here, I'm still going to get 0 in my denominator. But what I can do is look at that numerator, and I just rearrange my terms so I can make a clean comparison. Notice comparing this to this, I have opposite signs. You know, a negative V, positive 3, negative 3. So that means I can factor out a negative out of this numerator. And I have exactly what I have down bottom, which is V minus 3. You know, if I were to distribute this negative back, then that would give me back what I originally had, negative V plus 3. But I pulled the negative out so that I can go ahead now and cancel out V minus 3. And now I have negative 1 over 3V. For a most simplified way of expressing that expression. So now I can take the limit of that and have a legitimate answer. That'd be negative 1/9.
So I guess I should ask this at the beginning, but why could we not have plugged 3 into the complex fraction and just gotten the answer?
Not a problem. So when you plug 3 in right here, you get 3 minus 3, which is 0 in your denominator. And that will, that, you know, that's undefined.
Oh, okay.
Other than that, if that didn't occur, you're absolutely correct. Plugging it in and you would have been good to go. And that would have been whatever your answer. Yeah. All right, what else we got? Anybody else? Anything else?
I think that's all I had.
Okay. Anything else? Anybody else? Everybody good? Okay, I'm gonna do, I guess I'll do another problem out of 3-1 just to, like I said, just to show you what we got going on there. Let's see if I can find a good one. Okay, let's play with this one. Oh, 4. All right, so Same type of direction, find the equation for the tangent to the curve at the given point. And we have y equal to 1 over x cubed. And this is -2, -1/8. I didn't even look at the title of this section.
So is this part of the review or is this 3.1?
Well, it's 3.1, but it's still, excuse me, it's still the same things that we did. It's one of the same type of problems that you did still out of test one that would be in test one, like we saw earlier. So I just figured that we just do another one like that just to, get a little more practice in.
Oh, okay, I was just curious.
Yeah, not a problem, not a problem. Trying to find the title of this section. And of course, I didn't label it that way. Where we go. Tangent lines. And the derivative at a point. I'll just call it tangent lines. But it leads us into our next major thing that we're going to talk about, which are derivatives. And we'll get into that next class. We don't necessarily need to do that. But like I said, this is more so of a review of what we've done out of chapter 2. So let's go ahead and do that. So once again, y is the same thing as f of x. Difference quotient means we need to find f of x plus h. All right. So that's that. Trying to see, do I need to expand that? Let's do this. So we have a fraction. Let me see if when I put it together, there's a way to, this is what we have, and that's over h. How to multiply that times that? All right. I'm trying something real quick, guys. Don't copy this. I just want to see if this will work for us. So give me 1 second. So that'll cancel out this. If it works, I'll tell you what I'm doing. If it don't work, we'll just scratch it. So that would be x cubed minus x plus h cubed over it's looking messy down bottom though. Okay. Then the h cancels. Okay, so I was trying to get rid of the fact that we had these fractions up here. So I was leaning on the same principle that we leaned on with the last problem when we had that 3v and we multiply each numerator by 3v. So here, our denominators are x plus h cubed and the other denominator is x cubed. So what I did was I multiplied those two together and multiply each numerator. So we have 3 numerators here, here, and here. Multiply each one of those by x cubed times x plus h cubed. So that cancels out the fact that we have, a fraction. So you see that right here, but it makes our denominator a little messy. I guess we can keep rolling with it. And then keep going with it. Yep. and just leave it there. I'm going to leave my denominator like this. And I'm going to go ahead and expand this out, this x plus h cubed. So that's why I did one like this, since it was cubed. Well, first of all, is everybody okay? As far as copying, I want to scroll up if you still copying.
So we should write that down.
Yeah, let's go ahead with it and see what happens. Sometimes with calculus, it happens like that. You just go with things, see what happens. And yeah. So like I said, what I did was I wanted to get rid of the fact that I had these denominators. If I were to combine them, I still would have had the same situation. So yeah, so I just got rid of the fact that I had denominators multiplied top and bottom by this LCD of x cubed times x plus h cubed. So I multiply both top and bottom, or each numerator, by that LCD. And so next move is to expand that out so I can get rid of any term that does not have x cubed in it. I mean, any term that does not have, well, yeah, any term that does not have x in it. No, does not have h in it. Yeah, if you don't have h in the numerator, I need to get rid of those. So that's what's going to happen next. All right, so x plus h cubed is x plus h, x plus h, x plus h. Let me go ahead and fold this one out. Leave that third one alone until we finish with the first multiplication. So that first distribution gives us x squared plus 2xh plus h squared. Now we're going to take each one of those and multiply it to each term in that second parentheses. So it'd be x cubed plus x squared h, 2x squared h plus 2x h squared, x squared h plus h cubed. Combine like terms, x cubed plus 3x squared h plus 3x h squared plus h cubed. Make sure we're okay with that distribution. All right, so we got x cubed minus that quantity. Or that expression, I should say. All over h times so that minus sign needs to hit each term in the parentheses. X cubes cancel. All right, so that H can go into each one of them. More efficient way of writing it is just factor out that H. All right, hold up. So make sure I'm not losing. And yep, I thought so. So this is 3x squared, 3xh squared. So always got to make sure you hold on to these exponents. So I took one H out of each one of these, factored it out so I can cancel it with the one in the denominator. So make sure 3xh squared, h cubed. Okay. So now what I'm left with is negative 3x squared minus 3xh minus h squared over x cubed times x plus h cubed. So before we apply the limit, as h goes to 0, make sure we're okay with our cancellations and simplifications. All right, so now we need a limit as h goes to 0. So we're putting in 0 in each spot that we see h. So that cancels, that cancels, that cancels. These are negative 3x squared in our numerator. And x cubed, x cubed, x to the 6th. And then we can reduce that further to give us negative 3 over x. I don't know why I went so low. Over x to the 4th. All right, any problems with what we've done so far? Make sure we're okay. So now we can find our slope. If we evaluate this at the point that they gave us, -2, -1/8. So if evaluating it at -2, -1/8, that means x is going to be that -2. And we're going to plug in here. So -2 to the 4th power would be 16. So that's -3/16. And now we use our point slope formula. Yeah, that's not it. All right, so getting it from the point, and we just label our slope. Right here is our x1. This is our y1, as far as our formula is concerned. Everybody okay? All right, so taking care of negative to negatives, have that in both cases. So that'd be y plus 1/8, x plus 2 inside of the parentheses. Now we can distribute -3/16. All right, so if you were to multiply -3/16 times that 2 and the 16 and the 2 that you're multiplying it by can cancel out, and that'll leave you with just -3/8. All right, then we can finish it off by subtracting 1/8 from both sides. So our answer should be -3/16 x minus 1/2. Let me go ahead and throw it back in there and check. Oh, did I lose it? Oh man, I wanted to plug it back in there. Let me see if I can get it back. But any questions on anything I've done with this problem? Just changing. Okay, see you. Negative 1/3. That's right. Okay, cool. Yep, got it right. That was positive x 1 over x cubed, right? Yeah, okay, cool. All right. Questions on what we did? Is everybody okay? It's the same process. That one was a little more complex because it had the x cubed. So it calls for us to expand out more. So it was x cubed and it was in our denominator, which calls for more complication. But so that's why I did that one, just to give you an idea as to how you will handle that type of problem. But the process is initially the same when you're talking about finding your difference quotient. So you plug in x plus h, expand that out, subtract f of x from it, divide by h, then apply the limit as h goes to 0, and then plug in x from that point that they gave to get your slope, and then use your slope and the point that they gave in the point slope formula to get your equation. So questions, any questions? Everybody good? All right. So try the stuff out, see if you get stuck on any of them. And we can, do them again. Next class, I'll probably do another one, 3-3 from 3-1, but then most definitely we'll get into 3-3, which will take us into derivatives. And, go from there. So any questions before we close? Everybody good? All right. So have a great weekend. Be safe. And I will see you on Monday.
Thank you.
Thank you. Have a good one.